Cool, we're live. Hello, everyone. I think there might be some of you online tuning in a little bit early. Welcome to Green Tech Southwest. We are just getting set up. We are here in the engine shed, and my job is just to get you all acquainted with the physical space that we're in, so you have a bit of an idea of what we've got going on. The event officially starts at past, and then you won't hear from me on the mobile sort of mobile diva. We'll sort of show you the video from the front. I just thought I'd walk around a little bit to give you a sense of the space. This is also just a good opportunity for us to check that sound is working. And so here we go. Just going to check in with Sam. All right, cool. So here we are. We've got a little bit of networking going on behind me. Thanks to us. Oh, how well you can see that. Thanks to our sponsors, who we'll tell you about in a bit. We've got some food and drink for everyone. We've got lots of nice, friendly people, lots of chatting going on, lots of people making friends, and hopefully those of you that are online as well will be able to introduce yourself in the comments and also make acquaintances with each other too. So as I mentioned, we'll be kicking off officially at past. For those of you at home, as I mentioned, do introduce yourself on the comments. Let's get to know each other, and we'll be starting the event with some 60-second intros as well. 60-second intros are available to those of you online as well. You can come up, we'll enable your mic and your camera, and we'll broadcast you into the room, hopefully. Wish us luck with the tech, it's always tricky, but we'll broadcast you into the room and you can have 60 seconds to introduce yourself. So let me know in the comments if you are keen on doing a 60-second intro. So that's it from me for now. I'm going to sit down and start manning the chat. We'll start the event officially in 5 minutes time. Great, and we're so chuffed for those of you that have been able to join us online this evening. Thank you so much for being here and joining in. Cool. Okay, so yeah, show will be on the road in about 5 minutes time.
Yeah. Yeah. Hello, everyone. Well, I keep wanting to say welcome to an episode of, but it's definitely not that. Welcome to our first Green Tech Southwest of the year. Thanks for helping us kick off January and 2023. We appreciate you coming out on a dreary January day. We definitely think we've made it worth your while with 3 fantastic speakers. So yeah, I really appreciate it. So this is us. You'll see us milling around. You'll definitely hear from us throughout the event. But yeah, I'm Ellen. My name tag was fighting me all day, so it's no longer with me. But yeah, we'll come say hi properly after the talk. We've also got some fantastic humans who help us out, both with planning and running these events and helping me, Hannah and Mike resemble some sanity. So yeah, some of them are floating around as well. So again, don't be scared to say hi. So yeah, Green Tech Southwest, we're all about showcasing a variety of people using tech to solve different sustainability problems with ingenious ideas and methods. We basically just want to bring nice people together who have cool ideas about tech and sustainability. Our code of conduct is on our website, will be shared throughout the event as well. But yeah, it's very simple, just please try and be respectful and try and be very nice. So our wonderful super duper Green Tech developer has also developed a wonderful website for us. It is where we have all our past events, speaker interviews. This will also be up when we all wrap up as well. Give me a few hours. But yeah, you can see all our past resources there. Just see the cool people we've had on. So this part of Green Tech Southwest is just where we want to give the community an opportunity to, brag about whatever you're working on. Just get 60 seconds of fame. So yeah, we will open this floor up to both you guys in the room and online. Does anyone want to come down and shout out about anything? It could be anything. It could be something you're working on, or yeah, if you just know of something cool that people might be interested in. Yes, amazing. My first victim. So give you this microphone. This is just so that everyone online can benefit as well, and just project your voice.
Hello, good evening and welcome. A couple of things I'd like to give a quick shout out to, neither of which are in my domain. The first one is I had the pleasure last night to go to a film premiere by a young lady called Malati Weisjan, who is from Bali. Her and her sister at the age of 10 and 12 started a project called Bye Bye Plastic Bag, and they got rid of plastic bags in Bali. The government finally signed off plastic bags, plastic bottles, single-use plastic straws in 2019. So that took them about 8 or 9 years to do. They have a film which they have done, which looks at 7 young change makers from around the globe. It's well worth looking up, and it's called biggerthanus.film is the website. So please do check that out. Unfortunately, it's not in distribution yet. So if you know anybody who can help with distribution, please do pass it on. And the second thing, very quickly, if I've got a few seconds left, is if anybody has an EV or is lucky enough to know somebody who does, please do check out the London to Brighton electric vehicle rally.com, which is happening 1st and 2nd of July. And this year it's going to Brighton and then on to Paris to prove that range anxiety is no longer an issue. Thank you.
Dominic, a word of applause. Thank you. I'll make sure to grab all the links and everything. Yes, we have an online. Okay, in that case, this very technical bit. Please, could you mute the main mic, Sam? Anyone else in the room that wants it? Yeah, amazing. I'm sorry, Owen's voice is muted, so it won't be ominous. Do you want to introduce yourself and then
Sure. So hi everyone. Sorry, I did one of these last time, so apologies. It's me again. I'm Michelle. I'm a front-end developer at Edomwonyi, a data science and AI company working in the renewable energy industry and focused around making complex industrial processes more efficient. So we work with sort of various companies, and we also develop our own software in-house. It's a platform for wind turbine operators, which we've just launched with our first beta partners, which is very, very exciting. We actually have real turbines using our software now. And we are also looking for a front-end developer to join the team. So if anyone knows anyone, or if you want to come and speak to us about that role and what the company is about, what it involves, come and speak to me or Gareth, my colleague, who is also in the audience. Thank you.
Thank you so much, Michelle. Again, I'll grab your contact details and share them for anyone who wants to get in touch. How are we getting on with Owen? We have an Owen. Amazing.
Can you hear me? Hello, can you hear me?
Yes.
Yes. Okay, great. Not work me. So I studied renewable energy. I've worked in a wave energy startup for a bit, and then renewable heating. I currently work for Bristol Water as the energy and carbon manager. I sit in the water resources and environment team. So day to day, very much involved in routing water around our network with our automated pump scheduling system. So that's right from reservoir through the treatment works to tap. So that's kind of been my baby, as it were, since I joined 3 years ago. And more recently, since becoming energy and carbon manager, I'm now responsible for meeting net zero for Bristol Water. So that's quite a challenge. So yeah, very interesting subject to me tonight.
minimize Owen's screen and then. Anyone else from the crowd want to come down and brave a 60-second intro? Less feedback guaranteed if it's in person. Nope, all good. Hannah, have we got anyone else online? No? All right, brilliant. Well, we've got a few more bits to... Hannah's going to introduce some of the cool events we've got coming up. So I'll just invite Hannah on screen or in person. just get these back up.
What do I have to hold?
That one.
This one. Cool. All right. Hello, everyone. I'm Hannah, one of the other organisers. I've met quite a lot of you already. We're trying a slightly different order for things tonight because for those of you that come to our online events, at the end of our online events, we always tell you about other cool things going on in and around the area. What we realise is when we do hybrid, we're so desperate to get to the pub, we haven't actually been doing it. So we're doing it now and seeing how this format works. So one of the things that this community exists to do is to let you know about other cool things going on. We're a network, right? So it's not just about the people that come here. It's not just about the network that we have here. It's about the network that we build out in other places too. So there's two really super cool organizations that we would love to tell you about if you don't know about them. Is anybody here a member of CAT? Yeah, cool. All right. So some of you already know CAT. CAT is climateaction.tech. It's an online community. It's global. We've got nearly over 8,000 members. The cool thing about CAT is that everybody that is there is interested in tech and greening tech in different ways. So it's a really, really nice group of people. And as I mentioned, it's global. So you get a lot of really interesting perspectives. It's free to join. It mainly exists on Slack. That's probably the downside, right? We've all got enough Slack groups in our life. But if you can bear another one, I highly recommend. CAT has really kind of changed my world and has put me in, given me opportunities that I don't think I would have had in any other way. So I'd highly recommend CAT. For those of you that are based in Bristol, so obviously a lot of you in the room, we've also got a lot of people online tonight. There's about 30 people watching online. A lot of them are Bristolians as well, who just couldn't make it this evening. So relevant to everyone at home too. Future Leap Network based in Gloucester Road and also based in Clifton. Anyone here been to Future Leap events and know the network? Yeah, some of you. They're a really nice bunch of people. And it's worth having a look at what they've got going on. Can I just, is that simple? Yeah. Oh my God, we really have ironed this out. Oh, you wouldn't believe how hard this can be. There's a couple of other things we wanted just to let you know about, like specific one-off events or other cool things. The Bristol Green Capital Partnership. Folks, we're in Bristol. We are so lucky to have that community here. Again, does anyone attend the Bristol Green Capital Partnership group meetups? Oh, they're about to get 40 new members. Fantastic. Okay. Bristol Green Capital Partnership, really, really nice group of people. It's about green in its broadest sense. It's not just tech. The next mingle is, what have we said here? 2nd of Feb. So that's next week, next Thursday. Free to attend and really, really nice group of people. You're bound to learn something that you didn't know you wanted to know when you go there. For those of you who are perhaps more into tech, software stuff, there is the State of Open conference happening week after next. Is anyone planning to head to that? That's in London. I'm not sure if anyone is, but well worth checking out if you are. And then the last event that we have on our list down here is the Renewable Energy a solar and wind farms event that's based over in Cambridgeshire. It's an online event. We're good friends with the Cambridge group. Chris Poynton often comes to our events. I'm not sure if he's online tonight, but they're a really, really nice group and well worth having a look at that if you're interested in solar and wind farms. We thought, given tonight's topic, some of you might be interested in solar, so hence why we mentioned it. That's it for kind of community events outside of us. We promise we're going to get to the speakers that you've actually come to see very shortly. But I just want to tell you about what else we've got going on at Green Tech Southwest. Our next speaker-led event is the 28th of Feb. It's online. It's lunchtime, 12:30. And we're very, very excited. We really wanted to do an event on plastics, actually. So our next February event is going to be plastics themed, all about kind of different innovative plastics. And we've got Kelpie coming, who make plastics out of seaweed. Pretty rad. So Neil's going to come along and talk about that. And we're still trying, poor Mike is still on the case with our second speaker as well. And then following that, March the 30th, we've got Professor. I'm so chuffed that we have a professor coming to Green Tech Southwest. Professor Deborah Andrews, who knows everything there is to know about the data center industry and making that sustainable. Deborah's going to be joining us online again, 12:30. So check out those events. Please join us. And you'll have a warm Green Tech Southwest welcome, even when you're online as well. So yeah, we've got some tell us if you enjoyed the event, feedback, blah, blah, blah. I feel like we need some speakers now, don't we? Right. So to our main event, Dan, let's welcome you up onto the screen. Was the screen? Oh, it's all, yeah. And I'm sorry, I'm going to buy better quality name badges too, because I've got a malfunction like Ellen. So Ellen, I don't know if you need to help Dan, and introduce Dan and, cool. Okay, so bear with us, lift music.
Yeah. Okay. Yeah, that sounds good. Great. Sorry. Oh, the sharing.
The sharing.
Yeah, sure. Yeah.
Or can you invite Dan on screen? I knew that was too easy.
Yeah. Okay.
Ooh. And very funny again.
Oh, no. Yeah, you're right. Nose cam.
Nose cam, yeah. Underway.
Great. Okay. So I'll try and do this in 15-ish minutes. 15 to 20 even. Okay. All right. Great. Welcome everybody. Thanks for coming. Hopefully this will be interesting for you. I'm Dan Travers. I started in the energy industry 20 years ago in Australia, which was very much pre-renewables. Mathematician by training, did pure maths, realized there was no jobs in it. So energy was my sort of first real job. Very much old school coal and gas and a bit of hydro. But it was sort of in a trading and risk environment in the just deregulated energy markets back in Australia. But really interesting and slightly Wild West in style, but it did get me interested in energy as a space, I suppose, because it's an interesting thing where you need it and it's very present. You can actually touch it. You shouldn't because you could die. But it's sort of tangible, and as well as having this the sort of scientists in me quite enjoy it. It's quite complex, right? There's a lot of things happening in the grid and it has to be balanced at every point in time. So it's got a lot of interesting physics and as well as the sort of real worldness to it. So I then worked in, I think that company got bought and I moved jobs and ended up working for a energy sort of consultancy and software, and that actually brought me across here. So that's when I came across here. Worked in software as a product manager for many years, and then a few years ago wanted to get back into energy because I thought it was interesting, and started a PhD in solar energy forecasting, and then met a guy, Jack Kelly, and we started Open Climate Fix. Jack is a deep learning engineer. He was at Google DeepMind at the time doing wind forecasting, and found that interesting, but a bit depressing because it became quite clear that Google just wanted to do wind forecasting to trade electricity better to power their data centers. And he was slightly disillusioned at this. So we sort of got the idea, and then Open Climate Fix formed and started up very slowly. But then the last sort of 2 years, we've been growing and doing more real work and actually have real full-time people and so on. There's 7 of us now. Brad, who heads up our Bristol office, is present. It's quite a small office. It's quite a small office, but there's 7 of us, and we've got about 3 or 4 contract and interns. So, back to that sort of story about why did we become interested in it? I think I was interested in solar energy forecasting and what do the forecasts mean to people? So what do they cost and what's the impact of forecast errors? Jack was also similarly interested, and he did a bunch of stuff on energy disaggregation. So I think we'd both seen a bit of this stuff, and we'd both seen a bit of this stuff. And it became quite clear to us that there was quite a big disconnect between the two. It was very difficult for researchers to understand the problems of the energy industry and to maybe get data from the energy industry. So there's a lot of stuff in the energy industry you need data on. And the energy industry was often just too busy just doing the day-to-day and keeping things afloat to actually spend time on doing research and thinking of better ways to run things. So what we are trying to do at the super high level at Open Climate Fix is to sort of provide that tunnel. And we're not chopping the top off the mountain, which some people have said, to sort of provide this tunnel or bridge or whatever it is between these two groups, and by sort of doing research that's very practical, and it then ends up being something that can be implemented as a product. Here's a map. So what does this have to do with things? So the map is incredibly useful to understand your world. So if you want to, go to a new place, understand the world you live in, your domain, if you want to implement services and do things in that world, you're really going to want to have a map if you want to do it effectively. You can sort of stumble around and bumble from one place to the next. You can create a mental map, but you probably want to start getting better and better maps to have a better idea about what you're doing. The electricity industry is a bit like this too. So the analogy I sometimes think of for the electricity industry is there's a lot of uncertainty, and what they're trying to do is really map the present and also the future, because the amount of electricity flowing around, the amount of electricity generated, the amount of electricity consumed is constantly changing. So it's a map that's sort of in time as well. And interestingly, you might think that the electricity grid is incredibly well mapped. It's interestingly not. Right? There's significant problems still. There's a lack of knowledge about, especially in the renewable spaces, where solar panels are. So there's not a good asset register of all of the solar panels in the UK. There's the really big stuff is well known, but the smaller stuff is not well known at all. There's not a good understanding of where that stuff connects onto the grid often. And there's definitely not a good understanding of what the profiles are of that generation through the day. Now, why is that a problem? Because if you're planning the grid, you need to balance the electricity supply and demand to be perfectly balanced at every second. So there's this sort of spinning thing. There's this cycles AC 50 hertz. So every second there's 50 cycles of electricity goes through perfectly in time across every point in the UK, completely synchronized, these waves. And if that gets knocked out, if a power plant falls over, or if a big cloud comes over Norfolk, then that suddenly affects the shape of that wave, and they have to rebalance that to keep it back into perfect 50 hertz. They have to make sure the reactive power and the active power is balanced. So there's a lot of balancing that needs to go on, and there's a lot of unknowns. So what we're trying to do is be surveyors. You think of ourselves a bit as we're trying to survey this is the surveying corps of the Civil War, I think, in America times. One thing the North apparently did in the Civil War is they put effort into mapping and surveying, right? And it's quite a useful thing to do. So to some extent, I think of the work we're trying to do is really help use data to map and survey the solar energy on the grid now and into the future. So what is this a bit more tangibly, apart from that sort of high level view? Where does it actually matter? So there's three big areas: solar farm revenues, and that's something I'm looking at a little bit in my study, keeping gas off the grid and getting to net zero. So to cover those three, solar farms every day must submit a forecast of what they're going to produce tomorrow to National Grid, so that National Grid can schedule the electricity that's going to be generated and work out how much filling electricity they need, almost always gas, to fill in the gaps around the expected load, the demand, and the expected generation from renewables, wind and solar, plus expected imports from the continent, plus some nuclear, for example, which you basically can't turn off, in less than like a week. So there's sort of the fixed things, and then they've got to work out how they fill in the gaps in between with gas-fired generation, maybe a few batteries. If you, as a solar farm or a wind farm, any generator, get that forecast wrong, you have to buy and sell the electricity that you get wrong on what's called the balancing market. And the balancing market is where the prices get really crazy, right? So the normal electricity prices before the crisis were about £50 a megawatt hour. I think now during the crisis, they've gone up to 200, maybe 300, 400 even, like really high. The balancing market prices can get to thousands of pounds per megawatt hour. So this is just like orders of magnitude higher. So if you get the forecast wrong, it's most of the time not too bad, but it can be really bad, like, very, very costly. So we want to help solar farms be more efficient. So the better they can forecast, the less money they will lose in these forecast errors and on the balancing market, which ultimately means more solar farms. So because people financing solar farms want low risk, comfortable revenues, consistent revenues. Keeping gas off the grid. So as I said, all of that filling of the gaps is done with gas turbines. This is a gas turbine being built. It's basically a jet engine strapped to the ground, right? These gas turbines are kept in reserve to sort of fill in the gaps, and they can be turned up and down easily. Whenever gas turbines are kept in reserve by National Grid, that's quite inefficient. They burn a lot of unwanted carbon. And then they can also be turned up to fill in the gaps. But obviously you want to minimize these things because they're quite carbon intensive. And quite a lot of CO2, so 180,000 tons per annum of CO2 is due to these PV forecast errors. And we also estimate, someone has to pay for this. So we pay for it as ratepayers of electricity, anyone who buys electricity. The total balancing cost for National Grid per annum is 3 billion. Last year, it'll be a lot more this year. It'll be like 6 billion this year. Maybe if 10% of that is due to renewables, 5% of that is due to solar. These are like huge numbers, right? So the cost is also astronomical. This is National Grid. This is where they make the decisions. These are the people, the control room engineers, and they sit around with a sort of array of computers with weather and system information and outages and faults and transmission lines going down and all sorts of random things, storms, anything else. And this is a map of Britain's transition system. So it's basically Britain on its side. If you look at it, Scotland is on the left and the south of England is on the right. Bristol is bottom right, I guess, somewhere. And they're basically just trying to balance the electricity flows through there. So they are very interested in what's happening a day ahead, 4 hours ahead, and then minutes ahead. So they're sort of making decisions all the way down this chain. So what are we going to do for them? How are we going to make it better? Here's the video. Does it work? Yep. Even works live. So the super high level thing of what we're trying to do is use satellite images as an extra piece of information. Well, this is a animated image of satellite images, and these are solar farms or solar sites, not farms, just individual locations. And you can see the yellow means they're generating more, and purple less. And you can see night falls and they generate less, and so on. So we're trying to incorporate this extra information of satellite imagery, which, as you see, actually seems to reflect what happens to the solar panels quite well to help predict the solar panels better. It's also quite hypnotic. I find watching clouds form. I'm sure I could put you all to sleep. So how does this work? It's a joined up model using numerical weather predictions. So that's the number one way you predict the weather. This is what the Met Office does. Europe's got a weather service. these are these huge numerical simulations of the world, and they basically divide the surface of the atmosphere, also the entire atmosphere, up into cubes. It was about 70 cubes high and maybe 7, 9, 20 kilometer squares. And they simulate the energy flows between all these things, and they take hours to run. They don't resolve clouds very well. They're very poor at resolving clouds. They're quite good at, in fact, they're getting very good at big scale things like wind, temperature. They've primarily been developed for shipping and aviation. So most of numerical predictions were used to stop boats running ashore and planes crashing. They don't care a lot about clouds traditionally. It just hasn't been a big priority, right? And they're also clouds are often quite tricky to resolve individual clouds. If you imagine a big cold front, it's not too hard. You can see this bank of cloud, but when you get into the smaller individual clouds, it's quite hard. Satellite images, so picture so before, and we already know people in electricity, trading and supply and generation firms will use satellite images in an informal way. So they will look at the satellite image and go, it looks like the front's coming through earlier than expected, or later, or it's going to miss Norfolk, whatever it is, right? So they'll be sort of ad hoc or informally making judgments. So what we're trying to do is really combine that and formalize that through machine learning, to take an extra information source, which is the satellite imagery, and combine it with weather models. So these machine learning models, so the class of machine learning model is this multimodal, and a picture of robots. They can dance, these robots. What's interesting about them is that they take lots of types of information. So sound information, they have tactile information, and what's the floor, where is it? And they have visual information, right? So they're taking lots of information and assimilating it together to create a view of the world and then take actions. The nice thing about these multimodal models is that we don't need to necessarily reproject and fit the data over each other. So you're not trying to reproject these different data sources, satellites, NWPs, topographic data, onto the same grid. You just let the model sort of learn what's happening through time. I'm going to skim over this pretty quickly because I'm not the machine learning expert. So I've dabbled in it, but definitely this is where we've got the ML guys are looking at these models in a lot more detail, and it gets very deep quite quickly. Open source is a really important part of what we're doing. So as I mentioned earlier, we're trying to avoid the trap of closed IP. So we're trying to share everything we do, or we are sharing everything openly. So if you go to GitHub Open Climate Fix, you'll see all of our code, all of our issues are there. So it's completely developed out in the open. The idea is that we're trying to disseminate this knowledge as quickly as possible, so that we're relieving the sort of IP barriers block. It also means we get more inbound help, and I think there's a couple of ways we've got inbound help. One is we've had, I think, less than 100, but more than 50 people contribute code at some point in time, ranging from like helping a bit of documentation or fixing a bug or pointing out something, which is pretty decent, I think, quite good for an open source project. We've also gotten more data sets. It's easier to get data sets, we've found, if you are non-profit and open source, or definitely non-profit. I think the open source probably just goes with the non-profits. I think that is a bit of an easier conversation to have. And we're hoping also that this will attract tech talent, not so much to us, well, hopefully to us too, but also just to the industry as a whole. The energy industry is quite mired in very old tech stacks, and it's like a lot of Fortran and stuff they can't get rid of. So I think by being open and trying to introduce this way of working, we're hoping that will lift the type of skills and people that come to the energy industry a bit. And I should say there are other exceptions, like Octopus and so on, who are doing much more modern stuff, right? It's not only old stuff, but we see a lot of old. Right, I don't want to be too much longer. Results. Don't worry about the numbers too much. The big picture is National Grid's current forecast is quite a big error, and the errors get smaller as you go to the more different models and the more advanced models. Where does the accuracy come from? So we've got a bunch of sort of inputs. These are the categories inputs that go into the machine learning. So PV history is obviously essential because this is the history of what the PV systems are doing that you train on, and some of it's also quite near-term history, like the previous half hour, the previous hour. Right, so that's quite indicative of what will happen in the next half hour. Solar geometry, like what angle is the sun at? Weather forecasts, the NWPs, and satellite imagery. And what's interesting about this and sort of pleasing is that the satellite imagery is actually of that Earth observation data sources. It's a pretty significant part, right? So this is for the short-term forecast only, I should point out, like 0 to 4 hours. But so that short-term forecast, the satellite image is actually quite an important piece of information, which is encouraging, makes us think it's worth bothering with them. And it's got a nice user interface. So I'm not going to demo it. There's just some screenshots of it to give you an idea. This gives you an idea of the yellow is the forecast and the black is the actual PV outturn. You can see it's got that classic diurnal pattern going up in the middle of the day. And this gives you a map of where the irradiance is across the country. Or for an individual area, Melksham just there, which is quite near Bristol, has got the most solar installed capacity of any area in Britain, you'd be pleased to know. And that indicates, so this is actually where the power in megawatts, the other ones were sort of the sunshine, if you like. This is where the megawatts are being generated. You can see where the power panels are. The next thing we're doing is a sort of super local forecasts. So we're looking to try and take the same thing that we're doing for a national level and do it for individual solar panels, so individual houses and so forth. Looking to put even an app on a phone potentially. Do contact us if you're interested in being a sort of a test user of a forecast for super local, like household level or individual house, factory, solar farm level. So we're talking to sort of people with solar farms through to people with smart homes about this. And that is basically it. Good, thank you. Unplug. Good, yeah.
Questions for Dan after our next speakers. If you're at home, if you can fill in the ask a question section, which I'm sure Hannah's asked already. If you're in the audience, if you can hang on to your questions just a little bit longer, we'll invite our next speakers on, which is Melin and Andrew from Yellow Sub Hydro.
Have we got yours on? Yeah. No, we've got. Blue light? I think so. Blue light on?
Yes, is that okay?
Okay.
Level's good. Thank you.
You know, when you like.
Ready to rock?
Okay.
Let's go.
Hello, everyone. You're all. Hi. We are Melin and
Andrew.
and we are from Yellow Sub Group, which we'll tell you a bit about in a minute. And we're here to introduce you our software, which is reimagining water resource management. So, ahoy! I mean, there's going to be a theme of submarine. You're just gonna, because we are Yellow Sub, and that's what we do. So just go with it. Hopefully you'll enjoy the journey that we're in. We're excited to share it with you. Not many people, we've not like publicly shared it so many times. So you're some of the rare audience. So first I'll tell you a bit about what Yellow Sub Group is. We basically as a group are hoping to empower people, governments and organizations, but basically if you ask us or in a pub, we'll probably say, we're trying to help solve the world's big fucking problems by applying science, creativity, and innovation. So that's us like bigging ourselves up, but you've got to do that when you're in this game. So our purpose is to reimagine business and society for future generations and changing or having an impact, any impact on climate change issues by pairing technology with effective storytelling. So that's where these companies come together. So we have Yellow Sub Geo, Creative, Hydro. I'll leave at that because we are an innovative bunch of people. So we have new products and softwares that we're constantly working on. So we're going to focus on Periscope mainly today. Just quickly, Hydro is a digital water technology company. Geo is an applied science and geo-environmental consultancy. And us as Creative, we're a creative agency providing digital brand and web solutions for ethically driven businesses. So together, we are a group. Although we today represent Hydro and Creative. Hopefully you're still with us, because that was just the beginning. So, challenge of our time, and that brings us to why Periscope, because when we obviously saw this problem, we were all shook to our core, and it made us do something or want to do something about it, about this big and complex problem. It's clear that in the context of our global water usage, water-reliant sectors needs to do better or do differently in response to growing water insecurity. So what did we do? We, as Yellow Sub Hydro, has developed a catchment scale modeling environment, and we call that Periscope. And we do have a video to kick things off with to show you.
Deep down, you know it too. Yes, the mining industry needs models to help make sense of the world around us, but that's just the tip of the iceberg. It's the process and the decision that matters. A decision maker will take the findings of a model, aka that 50,000 plus word snooze fest report, to inform their decision making. However, the modeler's interpretation of the real world system seems to have been ejected from a black box that the decision maker doesn't understand. And so a communication gap appears. This communication gap exists because there is nuance and depth to a model that simply can't be shared in a report. This problem frustrated us too, And so Yellow Hydro developed a cloud-based application for near real-time simulations of coupled surface and groundwater modeling at catchment scale. No, really, it does all that. We call this interactive environment Periscope. Periscope bridges the communication gap between water specialists, engineers, and other decision makers by allowing your key stakeholders to see and even participate in the modeling process. With gained accessibility comes gained insights. Now everyone's invited to the party. More than just a model, Periscope is an entirely new system reimagined from first principles, with all the accuracy you know and rely on. Users can produce a combined surface and groundwater simulator with real-time interaction capabilities, share presentation and communication outputs to suit a range of audiences, or host shareable workshop environments among stakeholder teams, and a few other golden nugget capabilities that you can find more about later. We get it. Managing and communicating strategic water resources can be a real headache, with pressure seemingly mounting from all angles. From selecting the mine site to regulator and public engagement, our Periscope product helps you throughout the lifespan of a mine. Yellow Hydro is completely changing the game by democratizing access to data and decisions around water. All models are wrong, and that's okay. Together with Yellow Hydro, we can make better decisions around our most precious of shared resources.
Okay, cool. We're done. That's it. Thank you very much. We've told you everything. I'm standing in for Ed today, so forgive me if some of the technicalities don't come across. I get paid to draw. So this is, what we're playing with here in Periscope is looking at and addressing what the existing tools provide to us in modeling software and modeling principles, and really flipping it on its head, because traditionally what you end up with is almost a year's worth of effort to actually build and create that model, the water balance model. And then you start making decisions around stuff that's already happened in the past. So, the weather conditions and all that environmental conditions change over the period of time throughout the year. So for us, that was the massive shift in our thinking, is that why don't we build that model quicker and easier, and then start to iterate that model across the whole life cycle of planning what you do with that site. Next one. So doing that, we came up with this methodology. So all the boffins did, I didn't. So doing that purpose, driving the purpose of what we're trying to achieve here, gathering the data and the data sets, very complex global level data sets, disassembling all of it, testing that and iterating it, reassemble it, and then experiment on what that outcome and what the output looks like. And the reason why these circles get smaller each time is because as we look and investigate and interrogate that data, fix any problems and highlight any weather station data that may have some anomalies in it, we can then start to make it and train that model much easier, much quicker. So making the understandable transparent with the ability to revisit at every stage of the cycle was really important to us, because each catchment, so if you talk about where the water flows off a mountain range and into the rivers and waterways, that catchment will give us as much information as possible the more we train that model. Why is this important? Time and speed and efficiencies, as every other software development business that's in this realm will tell you that, time is of the essence, and the efficiencies you can create and save from it are really, really important. But what Periscope and what the team has put together is provide the ability to create actionable insights. Because the model is much quicker to build, we can then do scenario-based kind of planning and understand, what if you do this? What if you change this? What if you tweak these scenarios? That outcome is actionable because you can see it and it's transparent. The reason why the time savings for us is because most of the data sets, we're talking weather stations for the main part, are pre-harvested. So when other solutions, consultants, and hydrological modelers will spend that time building the data set and gathering all the data sets, we've done a large portion of that. So we can actually start to interrogate and investigate the data much quicker than what you could do in a traditional task, in the traditional project. So with doing that, we're also able to handle unpredicted situations like changes in weather, environmental condition changes. We can push that into the model and understand what those outcomes would be. So yeah, exactly, modeling the what if scenarios, and you can answer, being able to provide different sort of answers to stakeholders, because like we said in the video, you know, you're dealing with consultants, regulators, the local people and communities of where the model is being interrogated. For example, mining is the big one for us at the moment, because that's where the greatest problem exists, where they have 50-year legacy sites that they have to maintain over a large period of time, that they need to justify their usage of water and the consumption of water out of the natural environment. Jump on next. So in this situation, the model is the beginning of the conversation and not the end for us. We have to start at the base, and we have to teach it and learn it, and gradually disassemble and understand what pieces are more important to us and throw away the pieces that are not. But in doing so, the steps that we're looking to do is with the machine learning aspect of it. When you have weather station data that is so fragmented that may have massive gaps in the data because the sensor is broken, or it's not, you know, Dan, you're not in, you understand that world where you might have massive gaps in data. So the ambition there is to gap fill that with machine learning data that is inherited from the other stations around, time-based. So you've got to do that over a massive scale. And this is an example of the UI of Periscope that Melin will talk about in a bit, where we have those weather station plots. Some of them have been tagged with notes. We would like to use this one. We don't want to use that one. And that gives us the picture of the model and the catchment that we are looking to generate a report on. So yeah, understanding the scope of the model is really important. But the biggest thing and the driver for us is to really understand, from a regulator, from a mining operator, from the businesses that are involved in this world, is what happens when you get modeling wrong. And specifically in the mining sector right now, what happens if you get that wrong? And it is really, you know, tailings dam failures, ruined communities, loss of lives, and substantial fines for these businesses that have mismanaged the approach to generating a model. And jail time, because they had CEOs that have been put to jail for the mismanagement of the approach. So there's examples here where, you know, the Ghost Village in Mexico, where the Colorado River has stopped flowing down into the north of Mexico, and 40-degree heat, they have no water resource. It's basically cut off, and that is really heart-wrenching to know that something like that could be avoided by managing the water resource better, by going into the modeling and making better decisions around what we do with water. South Africa mine recently, September 2022, again, you know, tailings dam collapse, mismanaged, not understanding the extreme weather condition changes in a catchment and how that water is going to flow and affect the system. And equally, $70 million fines for mismanaging it. So it's really big subject matter, and that's why the regulators are trying to push for more stringent reporting and more ability for us to interrogate that data. So, yep. Next. So essentially what we're trying to do with Periscope is to provide a platform that has empowering stakeholders, providing faster abilities for us to scrape, aggregate, and ingest that data into a platform that is already sitting on the cloud. There already exists. The data is there for us to just explore. Embracing those anomalies so we can train a model and iterate it better. And a fairer way that we can collaborate and promote different levels of user interface, because as the tool stands, we're looking at the experts, we're looking at the hydrological modelers and the consultants for this UI, but the eventual ambition is that then we're going to provide it and put it in the hands of stakeholders, though, with the transparency around the catchment area, that we can start to actually show them what the real, picture of that catchment looks like. Here we go. And just, big statement here. Water is our most precious and interconnected natural resource. It sustains all ecosystems, communities, and economies from local watersheds to the seas. It's vital to sustaining our health, safety, and the environments in which we live and work. Simply put, water is life.
Yeah, so water is life, and yes, that's why we would like to put our expertise and knowledge and all our hard work into something so vital, and that's why we exist in the game. So I'm going to tell you a bit about our UX journey. I don't know if we got any UX designers, but if you're all in, oh, come on. Okay, thanks. I'm just going to talk for you. No, I'm sure everyone has something little to learn. So we started our journey with user journey mapping, which means basically us trying to understand how a user will get access to the software, because these softwares are, they're not just going to be on App Store on Apple, are they? So we were just trying to track down that whole journey and what will be the next vital steps for them, what info they will need from us, or what we'll need from them. And everything initially was in the minds of our genius engineers and hydrologist specialists. So a lot of hard work was just trying to understand. I mean, even trying to get to this point is, I guess, is days of work. It just looks really easy. It annoys me. So a lot of hard work was trying to understand what they envisioned and whether that was viable at the beginning. Then user persona exploration was, so this is the final workshop, but before that, our head of comms director has held many workshops trying to identify the different types of users. Then it led us to trying to focus our energy into what we call a power user, which will be the user that will use the app the most, like the hydrologists and consultants.
Yeah.
And then I think we have 2 more, but then the main thing for us was to have people, actual community leaders, so that us even identifying and trying to see the world from their eyes and what they would need, and how an app who doesn't need them to be the buyer or the end user could actually help these people. So that was the very big challenge, but that's always been at the heart of what we wanted to achieve, was to keep the people in mind. So next we did user interviews, which meant that we mainly talked to people who would use the app. Like, we have an incredible hydro specialist who's one of the main developers of this app. So we spent hours and hours, days and days with her. At the end, she said she's happy to not spend every day with me. Also, she's introverted and I'm very extroverted. So I think that was, her time to happily to leave me. So at this place, it was quite tricky, because our little UX design and nerdy mind is trying to understand all these complicated data calculations about mappings, the things I have no idea what they're saying or she's saying, and she works on them day in, day out. So it was all about listening in and live actioning. So I was doing all of this as she was speaking. So it didn't matter like how clunky they needed to be or they looked. It was like it wasn't about getting things nice and perfect. It was just about getting things out of her mind onto something that we can all see. Then you then your USB exploration. So to be honest, I don't know how we've done this. So it's just a lot of conversations. And like I said, our comms director, Laurie, is really great at bringing us together and getting things out of people, sort of tricks us into talking about what we all think. And the whole team, including the Geo team and Hydro and creative team, we've all had lots of input on how do we place ourselves in the market? What is our USP? How do we want to be perceived? And okay, it was like really nice and fun, sometimes challenging. We did that in any way we could, like on Teams. We're not very limited on our desks, so you'll see some of us on the rain walking around. Someone is driving. I think someone is photoshopped themselves into the conversation. The bottom one. So I guess that was a vital part, to always be talking to each other. Then this is finally where things started getting more collaborative, and our designer finally took things off me and he managed to make more sense and made it all very pretty. then he then held many sessions with our software engineers and hydro specialists. This is where they tried and make sense of the flow of the app and all the steps of the software. And this does not happen once. It's not finished at all. It's ongoing. I feel like it's never going to finish, but they are all patient people, and he's doing a great job just doing all these fig jammy things. See, I finished speaking and he hasn't stopped showing what else is happening. Then next is wireframing and UI design. So again, wireframing, prototyping, testing, and the UI side of things are iterations that we go through, and we're still going through. We keep revisiting the design and we keep improving it. We've added different modes. So basically we're showing you this, but it's already looking slightly different. Well, very different actually already, and the work is never done. Testing and moving and redoing and designing is an ongoing process. Oh, oops, sorry. Anyway, so this is sort of how it started. This is still wireframes at this point. They just look better than mine. Then we moved on to UI. So this is where it's sort of, yeah, too much stuff. UX challenges. Yes, so the first one, you won't believe it, but it's still a challenge to try and prove people how important UX is. I don't know how many talks I've done on this, but it's still a thing. And sometimes it's hard for stakeholders or even the engineers, bless them, to working on technical side to get them super on board, because some things can be seen as waste of time. Our processes, like, you know, trying to test things, for example. And then obviously they can't always see all the little details that we're working on and the hours we spend on a button, I guess, and or the color of it. So the initial conversations about UX is always quite challenging. Also, engineers are people who are working with data often, obviously, and they have their own way of working, and it really works for them, right? They are geniuses. So us trying to simplify what they do is probably a bit like, but why? I'm like, I've already got this, like I can build this on Excel sheet, right? And we're just like, yeah, but let us do this prettier. And they're just like, why? So it takes a lot of conversations. They do get solved, so never give up if you have that problem, because at the end it's worth it and they see it. Secondly, competitor analysis when there's no direct competitors. So we did, it sounds like we're a little bit big-headed, but there isn't a direct competitor that does exactly what we're doing, that is bringing the groundwater and surface water and concentrating on stakeholder empowerment as much as people empowerment. So it was really difficult, and all the softwares that are out there is closed software, so you have to pay so much money to get a license. So we held little sort of on the down low, like interviews with people who use them, or really relied on screenshots and like their own sort of descriptions of what their software does that's online available. So we couldn't do like a really deep dive of competitor analysis, but that's okay. Then finding our USP, I did sort of talked about that already. It's an ongoing thing, and you do really need that confidence boost about what you're about, and your team needs to be aligned. So we still have these conversations. So we had a focus on time, and then we realized there is really like more important things than time that we can actually use as a USP. So that's been fun, and being inclusive and accessible. So this is super important for us. We know that resource management issues of any kind impacts marginalized or smaller communities above anyone. So main difference that we wanted to make is not to make our software just about the end user, or not just about the hydrologist or mine companies, you know, and to see what we can do about the people that lives in those areas that Andrew was just talking about. And that is still our biggest challenge, because again, they're not the end user. They will hardly be using this software, but how do we design with them in mind? So we are going to introduce, I guess, in our future features that we will introduce. There'll be sections where things are a lot more transparent, and hopefully any common people who gets their hands on a report or not a model but a graph can understand what it is better than other softwares out there. I'm done. Talk about the data challenges, please.
Okay, so yeah, we are dealing with some pretty hefty data sets, right? So a mixture of existing weather station monitoring sites, which can be in the tens of thousands anyway, but also the customer or the client's data for that catchment, and satellite data as well, the geospatial or global data or mapping data. So when you combine all of these different sources and you're trying to put them into a piece of software then you can run scenario-based modeling on, you need to cleanse it, right? Not just because the data is different, but the fields are different from each output you get. The numbers are different from it. The formatting in which you get it is different. So we have to do within our methodology, there's a process there for cleansing and writing scripts to cleanse all of that data. Just for weather station data alone is a massive, massive challenge and a task. We've scraped the entirety of the weather station data for the North America, and cleansing that is no mean feat. Adding into that now, the next phase of that is the client and the customer's data themselves, who very often will just enjoy Excel, and we want to get it out of Excel into a usable format. Traditionally, what you will experience as well is that the client will want to keep it in their format because they're just familiar in Excel or CSVs, and we're trying to take it into a system, but also allow that format to come back out in a format that the client and the customer can use down the track. That doesn't happen right now. So a consultant or the team commissioned to do that work, the engineers and the consultants, hold most of that data. The mine site don't own the data sets or the output data for that report. So it's really important for us to understand how we're going to curate, how we're going to store that data securely, that is isolated from another customer's data, and maintain the data set in isolation. Yes. As you know, that is going to incur a massive, massive increase in data, just exponentially. So how we deal with it and how we manage the data on the cloud, what server stacks and what type of technology we deploy in order to embrace that is an ongoing challenge. There's nothing we've solved right now. AWS, serverless cloud computing seems to be the way that we're looking at it, and that's the credits we've got given to allow us to run our data to date. But we're seriously open to other considerations and efficiencies. The reasoning why AWS at the moment is the right choice is because of the security measures involved in that. We haven't come across anything else right now that can do the level of the security measures that we want to maintain, because we're dealing with some sensitive data as well as weather station, publicly available weather station data. So we've got to be very mindful as to how we isolate all of that. Sounds like I know what I'm talking about, right?
Does he?
Yeah. So we've got to really kind of understand, the green hosting and the carbon impact and how we can reduce and mitigate the amount of strain we put on every request, every query, every time you run a model. What does that cost? And we would really like to get to a point where we can actually demonstrate and show what that value is. Again, we're coming to the end here. What do we look for in this digital water future of ours? The aspirations is to democratize access to the data and the decisions made around water. Actionable information for key stakeholders so they can, they can feed back, they can respond, they can query, they can really sort of investigate and ask big questions of the organizations that are in charge of these sites. And then building bridges between the science and the behavioral change, because we don't have a technical problem, we have a communication problem, right? So it's how do we communicate better with what's actually available on the site? What is the actual water resource that we're dealing with? And how can we quickly switch and change it as you know, the environment changes. Transboundary thinking is a big thing because most of the sites will deal with a catchment in isolation, but they might be really useful information outside of that catchment that we can embrace and bring into it to give us better information about it. And lastly, you know, we want this thing to be co-produced by nature itself, community groups and the residents, and the businesses that are responsible for the upkeep of these mine sites. Yeah.
So, end of our talk. So please remember, water doesn't care about borders or self-imposed boundaries. Everyone, thank you.
There we go.
I did forget to put our things there, our Instagrams or anything, but if you want to follow our journey, we're Yellow Sub Hydro, Yellow Sub Geo, Yellow Sub Creative on Instagram and LinkedIn.
Thank you very much.
Thank you.
Get some chairs.
Yeah.
Hold
should we keep it?
Yeah.
Should we park in there?
You have that one.
Oh, sorry, mate. You can ask questions. Just pass this.
I guess so, yeah.
And this is where,
easy questions,
this is where I get my steps in and run up and give you the mics.
Yeah, thank you, Alan, for doing the running. Great stuff. So we'll take questions from the room, and I've got 3 from the people at home. So if you've got a question, if you can put your hand up, we'll start in the room.
Except for anyone at the top.
Great stuff.
Cheers. This question's for Dan. I was just going to ask, like, you talked about the National Grid's fee or fee system, penalty system for under or over reporting. Obviously, it's good that you're helping with reducing the degree to which people are under and over reporting. But do you think the system itself is like fit for purpose? Is there a degree to which the grid should be updating how that system works in your view?
Yeah, it's a really interesting question. So the electricity market was designed in 1989, right? It's a long time ago now. And it hasn't changed. It hasn't really significantly changed. So I think there's a few things that would, some things like that day ahead forecast, it's not too bad. However, one of the things that's happened is there's been a huge trend towards everything is happening much, much closer to real time now. So that day ahead now, probably you want to now replace that or maybe supplement it with a few hours ahead forecast where people can maybe reforecast their things. And then there's even minutes ahead. And when I entered electricity a long time ago, we used to do a lot of our trades for 5 or 10 years out with hedge, so to speak. Now I think people hedge days, months. Most of the trading is like days ahead. And that's partly why all these suppliers defaulted, right? Because they were very poorly hedged. So yeah, I think there's a number of changes. I think there's some market design change, which is, the electricity market and when people should forecast in and so forth to reflect, I think, a lot more real-time nature of electricity, and the variability of renewables is a huge new thing. So it used to be just load that varied, and now it's load and wind and solar that all vary, 3 huge factors. So that would be good. The other thing is National Grid is working on it, but I think they need to move a lot faster in modernizing the way they deal with this too. And this is a challenge for them because they've got very old systems and they're very risk averse. So I think there's 2 big changes that would be good to see happen, definitely.
Great stuff. Thanks for the question, Matt. Has anyone got any questions for Andrew and Melin in the audience at the moment?
Hi. Yeah, that was really interesting talk. I was just going to ask, I don't know a lot about like the mining industry or anything, so I just wanted to know what are some of the sort of decisions that like one of your clients might make based on using the software.
Our software?
Yeah, would it be to, build to maybe stop mining to reduce water usage in certain weather conditions and that sort of thing, or what?
I know I'm shaking my head, but I'm going to give the stand.
It is exactly that, really. So, you know, the regulator, every 3 years, it's a regulation that they require a report that comes out from the mining site. You know, it's a legacy piece of estate that they hold. So even after the usage of the mine has ceased, they need to maintain the kind of reporting of what happens on that site. And so that in itself is, they need to demonstrate what's the kind of the runoff, what's the consumption of the water on that mine, and where does that silt, where does all the rubbish go, and is it well maintained and captured so that it doesn't, you know, as you see, it doesn't ruin the local environment, poison the rivers and waterways, and cause massive uproar. So there's a serious amount of reporting that needs to be done to mitigate what they're going to do with that mine in use or after use.
In simple form, like, is there enough water?
Is there enough water? Is there too much? Where's it going if there's too much?
And where's the dirt or the terrible water gonna go out of from the factory or the mine site?
Exactly.
My simple language. Thanks.
Thanks very much. Got a question for Dan from Owen Smith online. At what size do solar farms have to submit generation forecast to National Grid?
Right, yeah, it's a good question. I think it's now 1 megawatt that is the balancing market unit, it's called. So it's you're a generation unit that participates in the balancing market, as it's called. So that's they've lowered that, I think, from 5 to 1 recently, but I could be wrong about the numbers. However, having said that, all of the suppliers, so most of solar is below 1 megawatt, so it doesn't need to report this in. However, all of the suppliers have got a lot of what's called embedded solar. So there's a lot of solar that's on rooftops, on factories, or it's small scale farms. It's, you know, a field, it's, you know, 20, 50 megawatts. So anyway, it doesn't matter. But yeah, small scale, but it's not a balancing market unit. So they still need to try and forecast their load that they're going to supply, and they buy for that. So even if you don't have solar farms, you basically, for all of the rooftop solar, you're subtracting that out, all of the rooftop solar out of your load that you're expecting. So if it's a sunny day, the suppliers are actually reducing the load that they're buying for. So they've got the same problem of forecasting, even though it's not as explicit. So they're still exposed in that way to a price risk.
Great stuff. Can we have another question from the audience here?
You all seem to be consuming weather data from various external sources and have pain points with doing that process. Is there anywhere that you would recommend is a good supplier of that information, or is everywhere terrible?
I can say one thing. So we are now a supplier of weather data. Not of weather data, satellite data though. So the weather data is licensed and it's difficult to redistribute. But satellite data, one of the things that we're doing for open data is taking all of the EU METSAT, so that's the European satellites, and projecting that onto a nice coordinate system and putting it online. So you can go to it's called Hugging Face. It's a weird, you might know it. Yeah. So Hugging Face distributes data sets and machine learning sort of, you know, artifacts. And so yeah, we've got a lot of satellite data out there, which is made for people to use. So yeah, totally encourage people to use it.
I didn't realize you were there. I'll go find your space.
Yeah.
Yeah, in a similar vein, really, with you know, the entirety of the data sets that we're looking at. There's multitude of open source, but it's very hard to find. It's not clearly labeled. You are scraping and trying to measure and balance what you've got against what's out there. The satellite data and the ambition of, you know, opening up opportunities with ESA and the UK Space Agency to getting hold of that data is, you know, would be great to be able to query it. So again, a nice blend, but it's not easy.
Thank you.
Great stuff. Thank you for that. We've got a question from home from Alistair. For Yellow Sub, is the model only based on machine learning, and how does the accuracy compare to traditional resource models?
Melin's taken now, she know. Not based on machine learning. That's the kind of future ambition, is to gap fill with that element of it. The accuracy is based on the skills and the kind of technical prowess of the hydrologists that we have in house, and getting that with their peers and consolidating that with their peers to ensure that accuracy is right. There is no real kind of measure apart from observable reality that you have out there with this stuff. So yeah, the model is giving you a reflection of what it finds from the weather data. So there is no, you're not fighting with anomalies, you're just filling in the errors that you can see. So there is a human element that needs to be applied here at every step. You can't automate a lot of this stuff. You have to do it in a manual, strategic way. So, okay.
And our software allows you to input, split, or add data, right, as the hydrologist wish. So okay, I did my bit.
Great. Thank you. Any other questions in the room?
I think another energy system question for Dan. Sorry. You mentioned there's such high prices in the microsecond market of like trying to balance that demand. So in the thousands of pounds, is there a reason there isn't just a load of battery storage companies that are essentially taking energy off the market and then basically profiting off that discrepancy? Why aren't we seeing more of that, basically?
The main reason is because they can't get the batteries fast enough from China. Yeah, so batteries are quite bankable now. So there's definitely, and now that electricity prices have gone completely nuts, and I should say very high sometimes, but also sometimes quite negative. So it does swing both ways. Batteries are, it's really just a supply chain issue at the moment. I think I remember when there's Solar Plus Storage conference where people selling solar and storage batteries in Birmingham every year, and there's it's quite interesting. There's lots of solar panels and solar panel cleaning machines, and switches and roof mounts. But the batteries, the industrial scale battery manufacturers, were not there in any presence because I think their order books are full. They don't need to sell batteries. Yeah, so there's I think the challenge is just the amount of lithium and stuff in the world and making them. Yeah.
Which is where we come in.
Yeah.
Help mine that stuff, but do it well and do it ethically.
Yeah. I've got a question. Can I ask a question? Have you used your work for hydroelectric sort of water filling, catchment area filling?
Not to my knowledge. You need to run that by the hydrologists themselves. But we've been exploring, projects in the UK that kind of any kind of body of water and how that kind of body of water is filled is of interest. So yeah.
And I know in energy people like long-term electricity traders look at that.
Thanks for that. We've got a question for Yellow Sub. Can you take weather forecasts and forecast an imminent risk like a pollution event? It's from Owen Smith.
I'm gonna say no.
Font of knowledge, me. I could honestly not tell you. I know the answer to that one, but it's water contaminants and water and how we can measure that would need external data that we don't have right now. But there's ambition to add those things in. So I think the perfect scenario, right, where you have historical data, there's an event, there's flood, there's contaminants, there's some serious situation that you need to understand. We're dealing with historical data that then informs future events and the what if scenarios. So if any of that has historical data attached to it, that we can look at it. But if it's an immediacy or a very short window of time in which that occurs, then I can say off the top of my head, I'd need to ask the real boffins.
Great, so thank you. One more question from the room.
So for Dan, sorry again. So you mentioned there's a particular problem with forecasting clouds. I was wondering if you do, or to what extent could you use sort of the data gathered from in real time almost energy that's being produced from solar farms to then predict where the clouds are moving?
Yep. No. Yeah, no, that's a great idea, and definitely something we're trying to do. Yeah, so we've only got about 1,000 real-time PV sites data. So every 2 minutes, I think that comes in. Yeah, if we could, we're talking to someone who might have a lot more. So yeah, if you're right, basically, you know, like that video that I showed, if you had all of the data from all of those dots saying, and you could start to track clouds, absolutely. Yeah, so I think that married with the satellite data is the best, because the other thing about satellite data is it's not always clear if it's a white cloud how much sun is getting through or how much irradiance. So some gets through, it's difficult to see. So if you have the ground readings and the top readings, it's
Best of both worlds.
Yeah. So yeah, good idea.
Great stuff. Got one more question from online. It's a question from Alistair to Dan again. Do you find it difficult to add satellite data into the process, or do you find it fairly easy to integrate?
Yeah, I find it really easy. You may have noticed I'm not doing it. I think it's quite hard. Yeah, I think it's just classic. I know just from looking at what we had on roadmaps, like we're going to download this satellite data, retransform it, and save it all to this cloud store in 4 weeks, and it took 4 months. So it just always takes longer. So yes, it's challenging. I would say though, if you're interested in doing it, please go and look at the data stuff we've got on Hugging Face, and hopefully we've done some of the heavy lifting if someone downstream wants to do it, and that's one of the things we're really keen to do.
Great stuff. That concludes the questions. So round of applause for our speakers. And it's over to Ellen to wish you all a good night, or hopefully drag you to the pub.
It's going to be very underwhelmingly quick. Just have round of applause for our wonderful speakers, and let's go to the pub.